Welcome to this video on solution chemistry, focusing on properties, concentrations, and calculations. A solution is a homogeneous mixture of two or more substances. Solutions have two components: the solute, which is the dissolved substance, and the solvent, the dissolving medium. Our key focus will be on understanding concentrations and calculations. Fundamental properties of solutions include uniform composition throughout and no visible boundaries between components. They cannot be separated by mechanical means. A solution maintains stable properties under constant conditions. Understanding these properties is essential for solution chemistry. Molarity is the fundamental concentration unit. It is defined as the number of moles of solute dissolved per liter of solution. To calculate molarity, convert mass to moles if needed, convert volume to liters, and apply the molarity formula. M equals N divided by V, where N is moles and V is volume in liters. Here is a practice problem to calculate molarity. Follow the steps outlined in the previous scene to solve this. The dilution equation is a crucial tool in solution chemistry. It relates the initial and final concentrations and volumes during a dilution process. This scene provides an example illustrating dilution calculations. It demonstrates how to apply the dilution equation to a practical scenario. Mass percentage concentration expresses the mass of the solute as a percentage of the total mass of the solution. Volume percentage concentration expresses the volume of the solute as a percentage of the total volume of the solution. Mass volume percentage combines units, expressing the mass of solute per volume of solution as a percentage. Parts per million, or ppm, is a concentration unit used for very dilute solutions. It represents 1 part of solute per 1 million parts of solution. Parts per billion, or ppb, is an even smaller unit of concentration, representing 1 part of solute per 1 billion parts of solution. You can convert between concentration units. For example, to go from ppm to percentage, divide by 10,000. Conversely, multiply by 10,000 to go from percentage to ppm. Let's work on a practice problem for mass percentage. Calculate the mass percentage of a solution with 25 grams of glucose in 175 grams of solution. The solution is 14.3%. Here is a practice problem for volume percentage. Mixing 15 milliliters of ethanol with water to make 75 milliliters of solution results in a 20% volume concentration. Finally, a practice problem for ppm. The concentration of 0.025 grams of solute in 50.0 kilograms of solution is calculated as 0.5 ppm. This scene displays common conversion factors that are useful when working with solution concentration calculations. To summarize, molarity is moles per liter. Other common units include mass percent, volume percent, mass volume percent, and the very dilute units of ppm and ppb. These review questions cover calculating molarity, converting between concentration units like percentage and ppm, and using the dilution equation.